Hello friends, here in this video I am explaining working principle, construction, application, advantage and disadvantage of abrasive jet machining process. Let me start with working principle. Abrasive jet machining working on the principle of abrasive erosion. If a high velocity abrasive particles or strikes on the workpiece, it tends to remove the some amount of material from workpiece. The velocity ranges between 150 meter per second to 300 meter per second. Here, commonly used abrasive particles are silicon carbide, aluminum oxide, glass powder, glass beads, and sodium bicarbonate. Sodium bicarbonate. These are the abrasives are widely used in abrasive jet machining process. And equipments used in this abrasive jet machining. First one, gas supply. Here, dry air or gas are used. Mostly air or carbon dioxide, nitrogen are used as gas because of its availability and uh, cheap and also toxic property. We are using here gas or air. And filter, compressed air sent to filter to remove unwanted particles and dust particles. And clean air is sent to tube, and here direction valve is here, which gives direction flow direction control valve is here. Here it gives control to the that high velocity air. And here pressure regulator is there, which is used to measure the pressure. Normally the pressure relief from the filter is 2 kgf by centimeter square to 8 kgf by centimeter square. This much of pressure is leaving from filter, and it passes to the mixing chamber. This mixing chamber, high velocity of air is passing this mixer, and here some amount of abrasive particles are poured into the mixing chamber. Here vibrator is placed because of proper mixing of air plus abrasive particles. The vibrator may be 50 hertz. This much of amount or vibrations are happened for proper mixing of abrasive and air. And it is passes high velocity of abrasive particles are passes to nozzle. Normally nozzles are made up of hard material like tungsten carbide. And the velocity of these abrasive particles are 150 meter per second to 300 meter per second, which tends to remove some amount of material from workpiece. These are the equipment setup. And let me explain applications of this abrasive jet machining process. It is used for drilling, cutting of hardened materials like metals, ceramics. this kind of materials can machined by using this abrasive jet machining process, and it is used for machining brittle materials like glass, and it is glass, we can say quartz, mica, etc. And it is used to manufacture electronic device, and it is used as deburring small holes. We can small holes can drill by this abrasive jet machining process, and also we can deburring small holes, and cleaning and polishing the plastic, nylon and Teflon components. Cleaning process and polishing process can be done by this abrasive machining jet process. And advantages of this process, we can say that is high surface finishing process, and thin section can be thin section can be machined by using this abrasive jet machine, and it is low initial cost, and disadvantages are high surface finish means low metal removal rate, and nozzle life is shortened, nozzle life is less, and it is not used to machine soft and ductile material. Soft material we can't use this abrasive jet machining process, and ductile materials also we cannot use this abrasive jet machining process. The material removal rate is depending upon the following factor. That means the diameter of the nozzle, which is ranges from 0.18 mm to 0.8 mm, and composition of mixtures. That means the mixtures of composition, air and abrasive particles, and hardness of abrasive particles and workpiece. Here we can use the silicon carbide, aluminum oxide, glass powder, glass beads or sodium bicarbonate, whatever it is. So the hardness of the abrasive particles and hardness of workpiece, we need to check the hardness of both. It can be the main factor of the metal removal rate, and particle size of the abrasive particles, and velocity of the jet, that means 150 meter per second to, which is ranges from 150 meter per second to 300 meter per second, and distance between workpiece and nozzle, tip. This normally the distance between workpiece and nozzle, which is 3 mm. These are the things we need to consider for metal removal rate. Thank you.